5. Acids, bases and salts. We use in our daily life a large number of substances such as lemon, turmeric, common salt, sugar and vinegar. Do they have the same taste? Let us recall tastes of some edible substances listed in table. If you have not tasted any one these substances, taste it now and enter the result in table. Caution 1. Do not taste anything unless asked to do so. 2. Do not touch anything unless asked to do so. Table substance taste sour, bitter, any other. Lemon juice, orange juice, vinegar, curd, tamarind, imli, sugar, common salt, amla, baking soda, grapes, unripe mango, cucumber. You find that some of these substances taste sour, some taste bitter, some taste sweet, and some taste salty. 5.1 Acids and bases. Curd, lemon juice, orange juice, and vinegar taste sour. These substances taste sour because they contain acids. The chemical nature of such substances is acidic. The word acid comes from the Latin word acre, which means sour. The acid in these substances are natural acids. What about baking soda? Does it also taste sour? If not, what is its taste? Since it does not taste sour, it means that it has no acids in it. It is bitter in taste. If you rub its solution between fingers, it feels soapy. Generally, substances like these, which are bitter in taste and feel soapy on touching, are known as bases. The nature of such substances is said to be basic. If we cannot taste every substance, how do we find its nature? A special type of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. The indicators change their color when added to a solution containing an acidic or a basic substance. Turmeric, litmus, china rose petals, gudhal, etc. are some of the naturally occurring indicators. Do you know name of acid found in acetic acid, vinegar, formic acid, and sting, citric acid, fruits such as oranges, lemons, etc., lactic acid, curd, oxalic acid, spinach, ascorbic acid, amla, citrus fruits, vitamin C, tartaric acid, tamarind, grapes, unripe mangoes, etc. All the acids mentioned above occur in nature. Name of base found in calcium hydroxide lime water, ammonium hydroxide window cleaner, sodium hydroxide or potassium hydroxide soap, magnesium hydroxide milk of magnesia. Can I test all substances to find their taste? No. Have you not read the caution? We should not test unknown substances. They could harm us. 5.2 Natural indicators around us. Litmus, a natural dye. The most commonly used natural indicators is litmus. It is extracted from lichens. Figure A. It has a mauve purple color in distilled water when added to an acidic solution. It turns red, and when added to a basic solution, it turns blue. It is available in the form of a solution or in the form of strips of paper, known as litmus paper. Generally, it is available as red and blue litmus paper. Figure B. A. B. Figure A lichens and B. red and blue litmus paper. Activity 5.1. Mix some water with lemon juice in a plastic cup or tumbler or test tube. Put a drop of the above solution on a strip of the red litmus paper with the help of a dropper. Is there any change in color? Repeat the same exercise with the blue litmus paper. Note down if there is any change in color. Perform the same activity with the following substances: tap water, detergent solution, aerated ink, soap solution, shampoo, common salt solution, sugar solution, vinegar, baking soda solution, milk of magnesia, washing soda solution, lime water. If possible, make solution in distilled water. Record your observation as in table. In your table, are there any substances on which litmus had no effect? Name those substances. The solution which do not change the color of either red or blue litmus are known as neutral solutions. These substances are neither acidic nor basic. Figure: children performing litmus test. Turmeric is another natural indicator. Activity 5.2. Do this. Take a tablespoonful of turmeric powder, add a little water and make a paste. Make turmeric paper by depositing turmeric paste on blotting paper or filter paper and drying it. Cut thin strips of the yellow paper obtained. Put a drop of soap solution on the strip of turmeric paper. What do you observe? To prepare lime water, take some water in a tumbler and add some lime tuna into it. Stir the solution and keep it for some time. Pour a little from the top. This is lime water. Table: serial number, test solution, effect on red litmus paper, effect on blue litmus paper, inference. Do this and comment this. You can prepare a greeting card for your mother on her birthday. Apply turmeric paste on a sheet of plain white paper and dry it. Draw a beautiful flower with soap solution. With the help of a cotton bud, you will get a beautiful greeting card. Turmeric paste, soap solution. Similarly, test the solution listed in table and note down your observation. You may try solutions of other substances also. China rose a indicator. Activity 5.3. Do this. Collect some China rose, good health petals and place them in a beaker. Add some. Now I understand why a turmeric stain on my white shirt is turned to red when it is washed with soap. It is because the soap solution is basic. Acid indicator base. China rose. Figure: China rose flower and indicator prepared from it. Table: serial number, test solution, effect on turmeric solution. Remarks: 1. Lemon juice, 2. Orange juice, 3. Vinegar, 4. Milk of magnesia, 5. Baking soda, 6. Lime water, 7. Sugar, 8. Common salt. Do this and comment this. Serial number, table, test solution, initial color, final color. 1. Shampoo, dilute solution, 2. Lemon juice, 3. Soda water, 4. Sodium hydrocarbonate solution, 5. Vinegar, 6. Sugar solution, 7. Common salt solution. Do this and comment this. Warm water. Keep the mixture for some time till water becomes colored. Use the colored water as an indicator. Add 5 drops of the indicator to each of the solution given in table. What is the effect of the indicator on acidic, basic and neutral solution? China rose indicator figure turns acidic solution to dark pink, magenta and basic solution to green. I am not getting the same result when using solid baking soda on dry litmus paper. Why? Make a solution of baking soda and then try. Paheli brought the following Paheli riddle for you. Coffee is brown and bitter is taste. Is it an acid or a base? Don't give the answer without any test. You are in the dark with its test. Activity 5.4. Do this. The teacher is requested to get the dilute solution of the following chemicals from his or her school laboratory or from a nearby school: hydrochloric acid, sulfuric acid, nitric acid, acetic acid, sodium hydroxide, ammonium hydroxide, calcium hydroxide, lime water. Table. Serial number, name of acid, effect on litmus paper, effect on turmeric paper, effect on China rose solution. 1. Dilute hydrochloric acid. 2. 3. Do this and comment this. Are you familiar with the term acid rain? Have you ever heard about damaging effect on acid rain? As the name indicates, the rain containing excess of acids is called an acid rain. Where do these acids come from? The rain becomes acidic because carbon dioxide, sulfur dioxide, and nitrogen dioxide, which are released into the air as pollutants, dissolve in raindrops to form carbonic acid, sulfuric acid, and nitric acid, respectively. Acid rain can cause damage to buildings, historical monuments, plants, and animals. Caution: great care should be taken while handling laboratory acids and bases because these are corrosive in nature, irritating, and harmful to skin. Demonstrate the effect of the three indicators on each of these solutions. Record your observation in table. 5.3. Neutralization. We have learned that acids turn blue, litmus red, and bases turn red, litmus blue. Let us see what happens when an acid is mixed with a base. We are going to use an indicator you have not used so far. It is called phenolphthalein. Activity 5.5. Do this. To be demonstrated by the teacher and the class. Fill 1/4 of a test tube with dilute hydrochloric acid. Note down its color. Note down the color of phenolphthalein solution also. Add 2 to 3 drops of the indicator to the acid. Now shake the test tube gently. Do you observe any change in color of the acid? Add to the acidic solution a drop of sodium hydroxide solution by a dropper. Stir the tube gently. Is there any change in the color of the solution? Continue adding the sodium hydroxide solution drop by drop while stirring till the pink color just appears. Now add one more drop of dilute hydrochloric acid. What do you observe? The solution again becomes colorless. Again add one drop of sodium hydroxide solution. Is there any change in color? The solution again becomes pink in color. It is evident that when the solution is basic, phenolphthalein gives a pink color. On the other hand, when the solution is acidic, it remains colorless. Base, acid plus indicator. Figure. Process of neutralization. When an acidic solution is mixed with a basic solution, both the solution neutralize the effect of each other. When an acid solution and a base solution are mixed in suitable amounts, both the acidic nature of the acid and the basic nature of the base are destroyed. The resulting solution is neither acidic nor basic. Touch the test tube immediately after neutralization. What do you observe? In neutralization reaction, heat is always produced or evolved. The evolved heat raises the temperature of the reaction mixture. In neutralization reaction, a new substance is formed. This is called salt. Salt may be acidic, basic, or neutral in nature. Thus, neutralization can be defined as follows. The reaction between an acid and a base is known as neutralization. Salt and water are produced in this process with the evolution of heat. Acid plus base to salt plus water, heat is evolved. The following reaction is an example. Hydrochloric acid HCl plus sodium hydroxide NaOH, 2 sodium chloride NaCl plus water H2O. Bojo added dilute sulfuric acid to lime water. Will the reaction mixture become hot or cool? 5.4. Neutralization in everyday life. Indigestion. Our stomach contains hydrochloric acid. It helps us to digest food. As you have learnt in chapter 2, but too much of acid in the stomach causes indigestion. Sometimes indigestion is painful. To relieve indigestion, we take an antacid such as milk of magnesia, which contains magnesium hydroxide. It neutralizes the effect of excessive acid. Ant bite. When an ant bites, it injects the acidic liquids, formic acid, into the skin. The effect of the acid can be neutralized by rubbing moist baking soda, sodium hydrogen carbonate, or calamine solution, which contains zinc carbonate. Soil treatment. Excessive use of chemical fertilizers makes the soil acidic. Plants do not grow well when the soil is either too acidic or too basic. When the soil is too acidic, it is treated with bases like quicklime calcium oxide or slacked lime calcium hydroxide. If the soil is basic, organic matters compost is added to it. Organic matters releases acids which neutralizes the basic nature of the soil. Factory wastes. The wastes of many factories contain acids. If they are allowed to flow into the water bodies, the acids will kill fish and other organisms. The factory wastes are therefore neutralized by adding basic substances. Keywords: acid, acidic, base, basic, indicator, neutral, neutralization, salt. What you have learnt: acids are sour in taste. Generally, bases are bitter in taste and soapy to touch. Acid turns blue litmus red. Bases turn red litmus blue. Substances which are neither acidic nor basic are called neutral. Solutions of substances that show different color in acidic, basic, and neutral solutions are called indicators. An acid and a base neutralize each other and form a salt. A salt may be acidic, basic, or neutral in nature. Exercises. Do this and comment this. Extended learning, activities and project. Do this and comment this. Did you know? Each cell in our body contains an acid, the deoxyribonucleic acid or DNA. It controls every feature of the body such as our looks, color of our eyes, our height, etc. Proteins that build part of our cells are also made of amino acids. The fats in our body contains fatty acids.